This is fluid coding and AI. 3 coding agents get the same GitHub issue. Copilot, Claude, and Codex can all produce plausible pull requests, but only one branch should merge. The real test is not who writes code first, it is who leaves the cleanest evidence trail. The question is bigger than Copilot versus Codex versus Claude. GitHub is trying to become the operating layer where autonomous coding work starts, moves, gets checked, and either earns a merge or gets rejected. By the end, you should know how to run a fair multi-agent bake-off, what evidence to compare, and where the workflow can quietly get expensive or unsafe. Think of GitHub as the control plane, not just the repository. The issue is the ticket. The agent session is the worker. The branch is the workspace. The pull request is the handoff. Actions, code scanning, secret scanning, and dependency checks are inspection stations. Human review is the release gate. That framing matters because agent quality is only useful if the rest of the delivery system can observe it. The current safe set to discuss is GitHub Copilot Cloud Agent, plus the documented third-party coding agents, Anthropic Claude and OpenAI Codex. GitHub says Claude and Codex can work alongside Copilot on asynchronous development tasks, create pull requests, request review, and iterate from PR comments. GitHub has also announced a wider Agent HQ and Marketplace Agent app direction, but the coding agent claim should stay scoped to the agent's GitHub documents today. Before the bake-off, setup is already part of the test. Copilot Cloud Agent runs asynchronously on GitHub and can be started from issues, PR comments, the agents panel, Copilot chat tasks, and automations. Partner coding agents are enabled through GitHub apps and administrator controls. This is where platform teams should decide repository access, runner policy, internet access, secret scope, budgets, and who is allowed to trigger agent work. Use one small issue with clear acceptance criteria. A good example is adding rate limit-friendly retry behavior to a GitHub API client. The agent has to detect rate limit responses, use exponential backoff, preserve existing error behavior, add tests, update documentation, and report the test command in the pull request. That task is small enough to finish, but rich enough to expose style awareness, test discipline, and review quality. Now assign the same issue to each agent under the same conditions. Same repository, same starting branch, same instructions. Separate agent branches or pull requests. GitHub says assigning an issue to Copilot sends the issue title, body, comments, and extra instructions, then creates or updates a branch and pull request. The important detail is that later issue comments are not picked up by Copilot. Once work starts, guidance belongs in the PR. The first comparison is branch and pull request hygiene. Did the agent choose a clean branch name? Are the commits signed and understandable? Does the PR explain what changed, what tests ran, and what risks remain? GitHub says Copilot sessions can expose progress, token usage, session length, tools used, validation steps, and session log links on commits. Those receipts matter more than a confident summary. Security validation is where GitHub's control plane role becomes concrete. GitHub says Copilot-generated code is checked with CodeQL, secret scanning, and dependency checks against the GitHub advisory database. Third-party coding agents receive similar validation. That does not prove the business logic is correct. It means the PR enters review with a standard set of automated safety checks before humans decide whether the change deserves trust. One of the most important safety details is easy to mistake for friction. By default, GitHub Actions workflows do not automatically run when Copilot pushes to a pull request. A user with write access must inspect the changes and approve workflow execution. That matters because an agent can modify files under .github workflows. Treat workflow approval as a privilege boundary, not a nuisance. Permissions are the difference between useful automation and reckless automation. Copilot Cloud Agent is limited to users with write access, remains subject to branch protections and required checks, and cannot approve or merge its own pull requests. It can use dedicated agent secrets and variables, separate from actions, code spaces, and dependabot secrets. Organizations can also control runner types and firewall behavior. Those knobs are not decoration, they define the blast radius. Cost visibility belongs in the scorecard. GitHub says usage-based billing is active for Copilot plans, and AI credits are the billing unit for Copilot business and enterprise usage. Copilot Cloud Agent, third-party coding agents, Chat, CLI, Spaces, and Spark can consume AI credits. Code Review can also consume GitHub Actions minutes. If you run 3 agents on one issue, you are not just multiplying options. You may be multiplying token spend, runner time, and review load. Benchmarks help, but they do not choose the merge for you. OpenAI says GPT-5 Codex is optimized for agentic software engineering and reports directional Codex evaluations. Anthropic reports strong Claude Opus 4.6 results on SWE bench verified with an important prompt modification caveat. SWE bench verified itself is a human-validated subset of 500 coding tasks. Useful signal, yes. A substitute for your repository CI, security policy, architecture, and review bar, no. The practical verdict is simple. Use multiple agents to explore options, but merge through one disciplined GitHub review pipeline. Compare the receipts, diff quality, tests, security checks, logs, cost, permissions, and failure behavior. The winning agent is not the one with the flashiest answer. It is the one whose pull request you can safely merge. If this helped you think more clearly about AI agents in real engineering workflows, like the video and subscribe to Fluid Coding and AI.